When evaluating the composite trig functions, there are a couple cases that can be a little bit different. First of all, when you have the composite of two inverse functions, such as the sine and the inverse, what you're doing is undoing what you just did. So that means that you are going to you're going to get what you started out with. Therefore, this is going to equal a negative 3/4, such as this one, which is 3 pi over 2. You don't have to evaluate this and take the inverse of it. You know you're undoing what you did and you end up with the same number, as long as you can take the tangent of this number or the inverse of that number. For example, if you took the arc cosine of 2, the question is, what is the cosine of what angle is equal to 2? Well, that does not exist, so there is no solution here. Now, there's one other, a couple other types of questions. First of all, if I were to look at number 6, you can evaluate this. Now, they're not inverses, so you have to do the inside first. And so you want the tangent of the arc sine of negative 1/2. So the sine of what angle is 1/2? The sine of pi over 6, but it has to be in the 4th quadrant, so that's a negative pi over 6. Then the question is, what is the tangent of a negative pi over 6? That's in the 4th quadrant. We know it's going to be negative, and that is going to equal 1 over square root of 3 by looking at the table or the unit circle. Other types of problems could involve something like this, where you have the sine inverse of square root of 3 over 2. And then you would know the angles. Inverses are angles, so that is going to equal pi over 3. So again, do the inside and then the outside when possible. Now, the only other type of problem is number 9, where they're not giving you a number for the inverse. And so what you have to do is a trick, which is to draw a triangle to help you solve this problem. And the triangle you draw should be a right triangle. So when you have an angle, you're just going to put an angle here, and therefore this angle is just going to be theta, and it's really x over 1. So this is your x, this is your 1, cosine of theta equals x over 1. This equals theta. Now, the question is, what is this? Because you have to evaluate it when you want to find the tangent of that angle, and you use the Pythagorean theorem. So it would just be what you're trying to find squared plus x squared equals 1 squared, and then you would see that this is equal to 1 minus x squared, and taking the square root of it. So the tangent of the angle, which is this right here, is equal to 1 minus x squared, and it has to be positive because it's the length all over x, and that's your answer. The trick here, draw a triangle, find the missing side, and then evaluate the trig function. So that's going to wrap up how to find a composite of trig functions.